Greetings! Well, it is a lovely Sunday evening in September, and I hope you are all doing well. What we're going to look at today, I know I've probably gone about this in a bit of a weird order compared to other instructors, but I wanted you to see what data sets looked like before we talked about all of the nuts and bolts of it. So we're going to start working in types of data sets, as in population versus sample, good stuff like that, and then we'll also start examining how to design a statistical study. But personally, if you have no relevance, if you have no example of what some kind of data set looks like, how are you going to know what is what? And that's kind of what we went through when we were looking at the difference between data and variables and types of data, types of variables. So anyway, here we are, and we are going on to look at types of data sets, sort of, and measures of center. So here we are. This is Shannon Math Chick Myers coming at you live from San Diego, California. So, as I said, I've been staying away from a lot of terms and definitions because I really wanted you to get a little exposure to real-life data sets so that, these terms and definitions would seem more relevant to you. Now is a great time to learn the difference between population data and sample data, and between a parameter, so the P's always go together, by the way. Parameter is always something that is about a population, and a statistic is something that is always about a sample. So here's the thing. There's this whole science, right, on making inferences, predictions, you name it, we do it. So what's the difference? Population, sample. Well, if you have population data, you don't need sample data. You don't need to make inferences. You know everything. You know what people think or the members in the group think. There's no need to make suppositions about the world at large based on a subset of the world at large. So kind of think about that as we go through with this video. Ready? Let's go. A population consists of all members of a group. Any numeric measure obtained from a population is called a parameter. No inferences need to be made about a population because you have information from everyone. When we're unable to collect the information from all members of a group, we often choose a subset of that group and make inferences about the entire group based upon the information from the subset of the group. The subset would be considered a sample. The inferences or conclusions made from analyzing the sample data are only as good as your sampling method. All right, so just like with the census, right? The census, allegedly, everybody fills out the census. And so allegedly, that is population data. I say allegedly because I'm not sure that everybody responds to that data. But the intent of the census is to collect information from everybody everybody in the United States, all right? Now, most of the time in real life, we don't have the ability, the funding, the reach to obtain information from the whole population. And this is where the whole science of statistics comes into play. I mean, it's kind of like gambling in a way. You make these judgment calls based on a subset of a larger group and hope you're right. But you stack your bets by using the correct sampling method, and correct being a very loose term. The trick is you want to reduce bias from sampling as much as you can so that the inferences you make stand up over time. All right, so we'll get into that more later, but let's check out this situation. So I sent out a survey to you guys. I don't think it was due until tonight, so I didn't use the information. But if I asked you about your opinion, our whole class's opinion, which represents 2 online statistics classes from MiraCosta College in San Diego, California, right? Whether pot should have been legalized for recreational use or not. Right? So and maybe I will survey you guys. So, okay, this information I collect from you, let's say we got a number from it. And let's say that 70% of you were in favor of pot being legalized for recreational use. Could I parlay that statistic? Or, I guess we should discuss that, right? It's a statistic if I'm using the information collected from you to make an inference or supposition about a larger group, right? Then that proportion would be statistic. But if I was saying, well, I surveyed my 2 online statistics classes, and this is the proportion that came out of that survey, and I wasn't making any kind of judgments or inferences about a larger group, then that would be a population parameter. If I make a supposition about a larger group, say all the students at MiraCosta College, are you, my 2 classes, representative of all the students at MiraCosta College? What do you think? I don't know. I would think because of the modality of the class being online, it's a general ed class, so a lot of people have to take statistics. My supposition would be maybe that you were a very good sample of the online student population at MiraCosta College, but all the students, I'm not sure. I think there would be bias. Are you answering truthfully? I mean, do you think I'll be judgmental and grade you lower if you say yes or no? So there's all these things that play into potential bias of a sample. And we'll explore that later. But certainly, I don't think that your opinion, my 2 classes of online statistics opinion about whether marijuana should be legalized for recreational use would be representative of everyone in San Diego. Right? There's so many different people, working professionals, homeless folks, they're the spectrum, right? I don't think that a sampling of 2 online classes at a community college would be representative, because you're going to school. I mean, there's certain things that are special about you, So, all the residents of the U.S., what do you think? I don't think so. We'll explore this more later, and believe you me, you can use this as a dissertation for a PhD if you want sampling. It's always one of those topics that can use refining, and people get better and better at reducing bias. All right. So anyway, kind of got off on a tangent there. As we journey through this class, you'll find that the same measures and their corresponding symbolic forms applied to population data and sample data have unique names and symbols. So you have to be careful, because in our graphing calculator, the only statistics that show up, or the only symbols that show up, are symbols for samples, because that is more true to real life. All right, so we'll talk more about that later in a technology video. Here we go. So, the number of members in the sample or population, and these are things that you need to put in your brain right away, especially the first ones. The very last one we'll go to later. But lowercase n always tells you you're dealing with sample data. Population data has capital N. So that represents lowercase n or uppercase n represents the total number in the sample. Now, the arithmetic mean, also known as the mean, also known as average, is represented like this in a sample, and it means X bar. That's how you say it. So if you see something that says X bar, then you know that information came from a sample, not a population. Now, if you see something like this, it's the Greek letter mu, or mu x, right? So I'm just going to do a note over here. That's how you pronounce it, mu, like M-U. Almost like moo from a cow, but mu. It's the Greek letter, and it always, all these Greek letters that you're going to see following always represent the population measure. Median. So median, you're going to see a little tilde over the X. And we'll learn what these things are momentarily. I just wanted to kind of get these out there. Now that we're, using all this technology, which means you guys are becoming computer programmers in JMP, a lot of times MED will represent median, but the traditional symbolism for median is an X with a tilde over it. And so this is pronounced X tilde, right, if you pronounce the symbol. There's no symbol for median in population data. And you'll also see in coding, you might see, sometimes people say capital M for median. In coding, you might see something like MED, and then you'd open the parentheses and you'd choose the cells. And we'll do something like that in JMP at some point. Probably sooner than you think, or maybe want. All right, standard deviation. Right. So the first two we talked about were measures of center. Standard deviation we'll get into a little bit later. This is measure of spread. And Standard deviation is represented with a lowercase s. In the graphing calculator, you'll see it as SX. Okay, so keep that in mind. For population data, it's going to be shown as sigma, potentially sigma x, depending. Right? And variance is just the square of the standard deviation. So it would be s squared, sx squared, sigma squared, sigma x squared. Now, proportions, we deal with proportions quite a bit, and the population proportion is just going to be a p. When you see something like this, that means it's a sample statistic, and it's literally pronounced p hat. So it's wearing a nice cheerful hat. All right, so most things in statistics, if it's an estimate or a prediction or something like that, you're going to see a little hat on it. Like when we deal with like a prediction line of best fit, then you'll see Y hat. Okay, but we don't need to worry about that now. Okay, test statistic. So the test statistics that we generally use are Z, and again, we'll get into this soon, T, and then something called chi-squared. So that's not meant to be an X. This is meant to say chi-squared. Right? And that'll be more towards the end of the course. Right? Okay, and then R, you may have seen this before in your work life or just in other classes. R is the coefficient of correlation. Right? So the R is the coefficient. Oops, coffer, that doesn't look good. Coefficient of correlation. And the R is from, using sample data. And if you knew it exactly, you knew everything. Whoa, that's no good. Then it would be something called rho. So this is pronounced rho. It's a Greek letter. Cool? So now we're in this section, we're mostly dealing with these three, but then the other ones will be coming along soon, so stay tuned. I don't want you to be disappointed. Let's get to measures of center. So a measure of center is a value at the middle or center. They're not trying to trick you, for real. Of a data set. There are different ways in which we locate the center of a data set. So depending on the type of data you're working with and how you collect the responses will dictate which measure or measures of center is or are appropriate for you to use in your descriptive statistics. Sorry, I should have had another line here. Okay, arithmetic mean. You've used this a lot, right? In averaging exam scores, figuring out different things in your life. People are usually pretty familiar with this. So it's found by adding up all of your numerical data values, right? You can't add up things like colors and stuff like that unless you code them in some way. And then dividing by the number of members in the sample or population, depending on what you're working with. So in statistics ease, the language of statistics, it looks like X bar equals. So this here means summation. So add them all up. So the sum of all your X's, all of your data inputs, divided by lowercase n. So what kind of data would that be? Beautiful sample data, because it's got that lowercase n. That implies sample data. Now mu, which is sometimes denoted mu sub x to be more descriptive, would be summation x over capital N, and that would be for population data. Now qualitative data, which is ordinal, all right, can be ordered in some way, like the Likert scale, satisfaction data. So if it's been coded using numbers, right, and it's ordinal, it has a meaningful mean, right? So if you coded satisfaction data from 1 to 10, right, and you got, you know, where 10 is the most satisfied and 1 is the least satisfied, and you were assessing an employee and the employee was getting 8s, right, then that employee was probably doing their job, right, in that category. So getting that average of all of the survey responses and having the data coded numerically can be meaningful. Now the median of a set of data is found by ordering the data, ordering the numerical data, and then locating the center, right? So if there's an odd number of data values, like if you have 2, 2, 3, 3, 8, right? And these are each, you know, entries. Well, if you count from the left, you have, you know, 1, 2, 3. If you count from the right, you got 1, 2, 3. You see the 3 is directly in the center. So that's kind of the easy way. There's only going to be one number in the center, whether you count from, you know, as you count in, you'll meet at one number in the center. There's an even number of data values. So let's say you had, I don't know, 2, 2, 3, 4, 8, 8, right? Well, if you count 1, 2, 3, you'd get to this one. Count from the right, 1, 2, 3, you get to this one. So what do you think you would do? Beautiful. You'd find the average of those two numbers. So 3 plus 4 divided by 2 is 3.5, right? So that would be the median. All right, so if there's an even number of data values, there will be two numbers in the center. So this was the picture for that. And this here was the picture for this situation. And so you'll need to find their mean, right, which you just learned, or average, which you've probably been used to hearing your whole life. Now the mode of a set of data is the most repeated value. Okay. If there's a tie, then your data is multimodal. So if you had two modes, you would call it bimodal. If you had three modes, trimodal. After that, you could just say multimodal, or you know, whatever number of modes you had. Again, you're going to want to order the data, right? And it's going to be numerical. in some way. If there is no most repeated number, the data has no mode. So qualitative data, which is measured by a count, uses the mode as its measure of center. So on some of those frequency tables, that the categories are qualitative data. Well, the data is qualitative. It's been coded numerically. And so the variable is a categorical variable, and it's measured by a count. Those are things that would use the mode as its measure of center. But you can use multi-measures. So if you have true symmetry going on, then the mode will likely equal the median, which will likely equal to the mean. All right. So let's check out this problem. All right. So again, real life data. Your poor instructor is learning JMP as you are, and I am also learning how to find data online. I don't know how wonderful this data is. This in particular came from Zillow, but I want to make it relative to us. So it's all this data, this table represents all of the cities in San Diego, all right, all in San Diego County. All right. So let's find the measures of center and check them out. So just to let you know, each of these measures is actually a measure of center. So the 2,389 that you see here for Vista is the median amount of rent that a person would pay in Vista, etc. So with the mean, what should we do? Well, add them all up, right? And then divide by how many? So 1, 2, 3, 4, 5, 6. Actually, if you keep counting, I'm sure you don't want to hear me count, you'll get a total of 35, I think. And then, so why don't you go ahead, pause the movie, and see if you get the same mean as I do. Okay, so the summation from I, so I would be the index of the summation from 1 to 35, because we have 35 of these median rent measures, and then we'll call it XI. So basically, what are we doing? We're doing 2389 plus 2533 plus ... until we got to 2605, which is Alpine, right? So when I use technology to find this out, because honestly I don't want you to add these all up by hand, what happened was I ended up getting a result of $2,992, right? So X bar, told you it was from a sample, is $2,992, and so you should always go one digit more, but we're dealing with dollars, so let's call it 70 cents, right? Isn't that crazy? The measure of center of rent in San Diego is $2,992.70. But that's just one measure of center. Okay, so let's see what happens when we do the median. So the median, we're going to have to crunch some stuff out. So what we're going to do is order the data. So I pretty much just check stuff off as I list it. All right, and I actually did do this by hand. So feel free to fast forward the video, but I'm going to write all of the values. So we had 1905. And I just kind of went through and checked them off as I went. So that was the 1905. We had 1965. Now I'm going to stop talking because I am going to fast forward this video for you, so you don't have to painstakingly listen to me go. All right. You try it too, okay? Now that we have it all written down, literally you just count, right? We know we have 35 values, and double check to make sure you got them all. I'm going to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5. 35 values. Okay, 17 plus 17 is 34. So if I count in 17, right, that 18th number should be the center because there's an odd number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. So 18. So the median is 2,389 buckaroonies. Cool? All right. Let's box our results. And this one, there was no rounding, but since we're in dollars, we'll just say 0, 0. The mode. Okay, were any of these numbers repeated at all? No, I didn't see any. So what would we say? Beautiful. There's no mode. Or none, or however you want to answer that. Okay, so I took the liberty of creating a bar chart for you in JMP. Isn't it beautiful? And color-coded the cities. I mean, what was the best measure of center? The city is a categorical variable. These things here, Coronado and Del Mar, if you live here, you know they're expensive. Rancho Santa Fe, woo, look at that. And Solana Beach, right? And even Encinitas a little bit. So when you add those values in, what do you think they're doing to the arithmetic mean? Right? Because these are just specific cities, right? It's not a frequency count. This is a measure of the rent. So what do you think is happening to the arithmetic mean? I mean, what did we get for that? You see it was higher than the median? So it looks to me like the arithmetic mean is not the best measure. Mode's not the best measure. So I believe the median is the best measure because the median is resistant to extreme values. I would definitely call the rent, the median rent in Coronado, Del Mar, and Rancho Santa Fe. Those would definitely increase the average when you're talking about the arithmetic mean. Does that make sense? Whereas ordering the data and finding the center, I mean, look at the numbers around it. 2380 was before the 2389, which was our median. 2426, 2460. I mean, look at all the numbers that are similar to that fall before and after. So I definitely think that the median is going to be the best measure here. Now, any issues with this data? What do you think about this data? I mean, I didn't have raw data. I didn't have, thousands of rent amounts in these cities. I had a measure of center already, didn't I? So what we're doing is we're finding the center of a measure of center, which is the median. So at least it is a measure that is resistant to extreme values. But, I mean, it's kind of been summarized already, so sort of homogenized already, hasn't it? So it's, always better to use raw data if you can instead of some sort of summary statistic. And we'll learn more about summary statistics next time, all right? So have a wonderful evening or morning or afternoon whenever you're watching this, and I'll talk to you soon. If you like this video, please subscribe.